Here's a Science Friday, friends. GIS data, Global Information Systems data, uh, Geographical Information Systems. There might be a few other phrases the acronym might be said with or around, but basically this is computer data with very specific attributes about it. So typically to be GIS data, it has to have a timestamp on it, a location stamp on it, and some reason for the measurement, I suppose. But most of it goes and gets stored somewhere. So GIS data is a huge, huge field of data studies. It is statistics, it is differential equations, it is statistics again, more statistics, and then you can start to make sense of huge amounts of data. So I'm bringing this up because the National Academies of Sciences is doing seminars on GIS data and data analysis, and probably the most important aspects of this is the math surrounding GIS. What you can and can't do to drive information out of huge data sets. The GIS data, that timestamp, the accuracy of the timestamp matters in high precision measurements. So if the timestamps on two measurements on the other side of the planet are correct, you can compare them to each other. So this is the relationships that the information inside of this big data, right? GIS, big data. It's big data structures, it's definitions of the data structures. So if you go use latitude and longitude, there's a number of ways to denote that. So some of them I recognize, some of them I have to go figure out how to convert them to whatever I need. So if you want some confusion, try using some GIS coordinates. And there, like I said, there's a few different kinds. This is what standards organizations do. So that timestamp and the source of the timestamp should define how accurate the timestamp is, right? If they're using satellite data to set a timestamp, if they're using a cesium clock, the absolute time, the absolute relative time, right? So there's a 24-hour clock going around the clock. There's a difference of, so those angular measurements are another way of doing some GIS data identification. So there's a number of ways you can put the data in just for a location. If it's wrong in the data set you're looking at, you either have to be able to convert it to something useful. Now you've done a data conversion, which needs to be recorded somewhere as a matter of record so that you can have confidence in the data set. This is called chain of custody. Very standard thing in high precision measurements. This is why the view of a black hole using Earth-based high frequency imaging needed a timestamp so precise to be able to compare the movement of electrons in time. Now, if that's not difficult to speak, imagine how difficult it is to understand why you would even want to know where an electron is in time. So that's one of the uses of GIS data. CERN depends on a clock precision. I am guessing. The clock precision is out 20 digits of accuracy. If you can imagine what it takes to get 20 digits of accuracy, you're down there trying to look at subatomic particles. You're looking at the electron and not the element or the molecule. And that's a very difficult picture we are just getting closer and closer to taking. So that's GIS data. Even though it's for something so tiny, so quick in time that it really doesn't make a difference to life generally, then that's the precision you need on the data, the precision you need on the location and the time of the data. And then we work backwards. We find an old rock and we use a precision instrument to measure specific elements and isotopes in the rock, and we can say when and where the rock was formed and exactly what it's made out of. This doesn't identify a calcite or the names for rocks that geologists are usually familiar with and work with, and that is what their profession speaks around. But it is a subset or a superset or an extension of knowing your rocks, to know the elemental composition of the rocks. So elemental composition, isotopic identification can identify compounds from space that weren't made on this planet. This is how good we've gotten at these measurements. So this term GIS just added more rules, more clearly defined rules on collecting data for doing informational research. This is stochastics, that capital STO word, that's looking back at massive amounts of data using multiple analytic techniques that each one's a book, each one's a semester at least to understand. And then you have to go apply it somewhere or you still don't get it. So that is GIS data made easy. It is national standards, but they can be unique to an organization or a body of knowledge or a tower of knowledge, however you want to picture your basket and the weaves. That's GIS data. The reason we look at it is we can see a star collapsing with that high of precision. We can see an electron orbital with that high of precision. We can begin to perceive an electron orbital. We can begin to talk about quantums. Quantums are not an individual measurement, period. A quantum is a summation of information. That's really all it is. So it is a human derivative, something we've created to try to understand something else. And now we're talking about making computers out of quantums. And the interesting thing in that, it is memory and programming married together. It is no longer an analog construct. It is a multivariant construct, which Plato would very much have a problem with, very much so. So philosophy is good to think about in here, but it's not what's driving where we're going. This research is the future of our civilization, potentially, or it can destroy our civilization and put us back into the ice ages. Put us back into the days where gods had more power than people did, which is odd because these are human words we're playing with. So the complexities of life are well misunderstood. How people come to conclusions, how people use numbers and zeros in their conversations. The context and the audience matter. If you don't know the zero they're talking about, you may be being played. You're being drawn into a rabbit hole that the author, the creator, needs to be shown around. And those are long conversations. These aren't, chats on the text chats. So GIS data and databases, database structures, database integrity, information integrity. You see, it was information that crashed Boeing's plane. It was information from possibly a single instrument that overrode all the other systems in the Boeing plane. It was a purely data-driven decision based on human written algorithms that were tested and apparently tested and released improperly. This is GIS data. This is the clarity of information with the precision I'm speaking to and what it can mean. It means when you go into a court with this kind of data, there's no debate but about how it's interpreted. So now you have to understand the data. Game of Thrones didn't introduce anybody to data, but it introduced it to kingdoms, the idea of kingdoms, and the dragons that can be drug around the kingdoms as the excuse for the debauchery of humans. So, data, GIS data. In my professional travels, my most valuable people were database experts. And these are some of the largest databases that you can fathom, and they're real. Databases about vehicle repair information, warranty information, crash information, databases about medical information. I'll get on that next. Databases about environmental information, databases about... So these things are all underneath us. This is data information. You can do real time to tell you where to go shopping and the next item you want to buy. Or you can do it slow motion and try to figure out how dinosaurs moved. The amount of information in data can be immense. The old saying before these days was a picture's worth 1,000 words. So if you extrapolate, television is a picture every 50 seconds, 40 seconds, depending on the frame rate in the old days, and depending on the dithering of your display in the new days. And some people call it Pantone, and some people call it RGB. So data has the same problems as measurements, because data can contain measurements, and if the name of the column isn't right, isn't clear, the next person using the data might misinterpret it, might misuse it, might make a mistake. So then you go into peer reviews, which is very much a higher level college activity, although your teachers are your peers in class. When they grade your paper, they're grading you as a peer, someone that can judge your ability in a specific skill set, someone that can maybe help you, or you help them to find an answer to a question that they're struggling with, or to prove a question they're struggling with, or to learn, or that hard. It's really that hard to have an open mind to this. So what does GIS data is a huge, huge, it's like saying God. You know, it's one of those G words that has a huge meaning, that inside each denomination, behind each pulpit, is subtly used, but the audience knows the context. This is education and knowledge, and a body of knowledge, because we build on the people around us. We learn from them, like it or not. You aren't in this by yourself, or you wouldn't know what a watch was. So, life in GIS data. I talked before. Another video talks to OSI layers, operating system interface layers, of which one of the towers in there is the IP layers, Internet Protocol, and that interface. That is only one OSI device, is an Internet Ethernet card, or a Wi-Fi card, or it's a CD player, or whatever other devices are out there in this OSI world of computers. This isn't our world. Even a programmer is removed from this world. A programmer calls memory. He doesn't tell memory how to get called. So this is data. This is information. This is knowledge. This is sitting in classes and listening to other professionals and having conversations that work through these kinds of details. That's GIS data. The largest holder of GIS data on the planet is probably our medical databases. And that's hard to believe, isn't it? But there's two databases that are fully understood and watched by the government, and that is healthcare. Medicare and Medicaid patients have the most extensive and thorough and comprehensive tracking system once you are in that system. Otherwise, it's all split up, broken down, intentionally private healthcare data systems. Do they talk to each other? Yes, for money. They talk to each other. It's expensive to get them to talk to each other. It can take 6 months to develop an interface that's reliable between two disparate systems. In 3 of those months, we're negotiating license agreements and security agreements and the required training to have the license access and the security knowledge that you have to have. So it is complicated, big, complicated office business structures, decision trees that end up in a yes or no in a boardroom to do funding for. So writing the justification for that funding on paper is pages and pages and references to things that hopefully the people at the table value, maybe understand, or they're going to talk about it. So GIS data, databases, as I said, as a field, as a profession, the database itself is huge. There are choices, there are options. Most people have heard of Oracle. Most people have never heard of Paradox. They've heard of Excel, they've heard of Access, they have heard of structured file systems as databases. So there's a capital SAS company out there and a few other competitors, and a whole lot of analytics software relies on files instead of databases, because they're just huge files. It's easy to access a file once you know the structure of the file, so leave it there. That way it has data integrity, Because remember that chain of custody. If I move a data set, technically I need the record of the move, and I need to know that the original data is solid. So it's actually a court, it is legal documentation at that point when you're stepping through information systems data. So we access Medicare and Medicaid data. Very, very secure. Critical systems, well-tested systems. They were real-time at one level in a doctor's office, and they were transactional in the background to a banking system and bill paying. And there were all kinds of agencies looking at data for theft and graft and grift and prescription fraud. But that's the Medicare and Medicaid data system and structures. It is not the private healthcare system. It is a lot of money in between those two to make them talk together. So GIS data, it's a very subtle thing. It's your Excel spreadsheet could be a piece of that, but more likely your IPv6 data packet has everything. It is a GIS data structure. It has tracked you from wherever that device is all the way to wherever the device is talking to, and who knows what in between. If it goes overseas, the NSA is definitely involved. The CIA is definitely involved, unless you're rich and then you have a pass, right? So that was the Friday 20. Again, it could go on and on and on. My introduction to GIS data was roughly 40 years ago, and it was our water quality data for aquifers across North America. Federal data, federal funded. Exxon made decisions with that most people would never consider. Peace out. Apple pie and hot dogs. Raisin bread and toast. I don't know, but maybe I do.